Welcome to Cloud Native Resiliency Patterns from the ground up. Thank you very much for coming in such a high number today. I'm a bit nervous because this is my second in-person event and haven't seen a lot of people in the past year. First of all, I would like to say that on your seats probably you found a flyer. That one has a QR code on the back of it and contains access to a book that two of my colleagues have written. It's about modernizing Java apps. It has very useful code. It works. And please use that free book and that flyer to get your own free book. Those said, first of all, I am Anna, the nervous one. I work as a developer advocate for Red Hat. But earlier this year, I became a Java champion, and I also certified myself as an architect. I've been an architect for some time, and now I moved to a developer advocacy role. But what I like to share, I mean, the most important change that I did this year is the fact that I moved from Romania to Netherlands. And I currently live here. This is why I was able to come in person way more easier today. And I'm very happy that you have welcomed me. And the reason why we're having this talk today is because I am a control enthusiast. I mean, that's why I went to computer science, and that's why I'm into programming and learn so many stuff. Probably like many of you, I like to control things and have things under control. So this is why we have this talk today. And first of all, let's start with what is resilience. Of course, I could give you the definition of resilience, but that is something that you find over the internet, and it's easy to be found. But in simpler words, from my point of view, resilience is that situation when an unexpected condition occurs from external of your application, so from outside of your app. Your app is going very well. It's normal behavior, right? But then it turns red. It's not as normal as before. That's because an unexpected event has occurred inside your app, and your app is not behaving as normal as before. And gets into a state called faulty behavior. Now, that faulty behavior state can be somehow detected thanks to a detection control mechanism that probably you code that recognizes that malfunction. Based on that recognition of the malfunction, you can have feedback. So you can have a feedback control mechanism to mitigate that malfunction. And yes, you get into the degraded mode behavior of your system. You know, when you're using the fallbacks and you are still having your application available and replying something to your users, but it's not exactly like the normal time. Well, until then, you are working on a degraded mode behavior, even though that, and the best case scenario is that your end users don't feel that. But last, there is a recovery control mechanism that you implement that restores expected behavior, the one that's normal and it's nice that we want to get to. So this is in a nutshell about resilience. Now, what can we control from resilience? Of course, we cannot control unexpected events and unexpected conditions. But what we can control as developers is these three. We can make the detection control mechanism, we can make the feedback, and we can also have control over how our application is recovering. And in today's talk, we're going to look at multiple levels on how to do that. First place, where to start. Now, I put this picture here just to scare you a little bit and to wake you up after lunch and make it bigger to be even scarier. But we're not going to start with this picture. This is like homework. You are looking at it at home when you would like to remember what I'm sharing today, because I'm going to code for you, so we don't need to look at the picture. Those being said, I will have an activity microservice that I'm going to work with today. And this is a Quarkus microservice that's very easily created from the Quarkus app. It's running with Java 17, by the way, because Java 17 is the newest version of Java, and we all love it, right? And in this service of mine, what I'm doing, I am consuming some information from a real API, which is this API, Board API. Now, the Board API, what this one has activities for the situation when you're bored. It gives you ideas what to do when you're bored. It's a free API, and it gives you a good idea what you can do, like on different types, on social, and on other parts. And you can even define how many participants do you want to have in those activities, and gives you information about that too. So we consume the information from this one, right? And the reason and how we consume them, well, with Quarkus is pretty simple. You define an interface, in my case, activity service, and you just give the URL to the boardapi.com, and you consume the service really nicely in an activity service interface that is annotated with register as client. So that easy. Now, it's a resiliency talk, right? So we need to fail things. Let me go here, and instead of board API, let's use board APIs, which doesn't exist, by the way. And yeah, let me start my app. First of all, let me check I'm Java 17 and say MVN Quarkus dev, because I firstly want to work in dev mode and see how my app is behaving. It has a problem. I don't have internet. Let me check again the internet. Oh, this one works. Then why didn't this one work? I did not expect it for this to not work. MVN Quarkus dev, come on. Weird. Let's move over this one and explain the concepts without the app, although that would have been more fun in the live mode. So getting back to our talk, let's add some resilience to our methods that we are consuming from a third party that now is unstable, is not existing. So the board APIs, let me get it here. Yeah, they do not exist. Cool. Those being said, let's make this thing resilient. First, what many developers would think of, let's add a circuit breaker. Yeah? And what the circuit breaker does, it's using failure ratio to know like at what percentage it should open the circuit. And we're going to say like at 75%. But it's good also to know when to at least try to close the circuit and use the real thing, right? So you need to add like a delay for that circuit to become closed again so that you can consume the real app. And I'm going to use the default here to 5 seconds. All good, right? But the thing is that when something is failing, you don't know how much time it takes for an application defaulty endpoint to respond to you. It can be forever, right? So to check upon that, maybe it would be good to add a timeout. And we'll put like 100 milliseconds on this one. So if the request is taking more than 100 milliseconds, the timeout annotation will throw a timeout exception. Thanks to that timeout exception, another annotation can be used, which is retry. And retry still believes that things are working. And what it does, it checks a few times that maybe your things are not as bad as they are. So that max retries 4, and then let's add some delay because maybe the service will become back and available in some time. Now, again, 100. It's all good. I mean, we're now having retries, but if things are still failing, we need a way to like give an answer to our users, right? So let's use that fallback to give them at least something default, or at least to those that are interacting with our microservice to know that something is returned, but is not as great as the real thing. And on this one, I'm going to say default basic hobby dot class, and let's create it. Created an inner class, and let's go here. But wait, Java 17, record. Let's make it record, because I'm using only here this part. So I can also declare it like this, and use a fallback handler having basic hobby. And now let's implement the default logic. And now implement methods in handle. This one is going to return a basic hobby dot empty, so an empty basic hobby. Now let me check again. Maybe this one starts. It doesn't want to. I would have loved to have seen this running and show you how it's behaving. Trying to think what I can do, because I don't have an image of it not running. And you have to take my my word for it, or come by the Red Hat booth. Maybe the internet is going to work for me there better. But this is how you can do the resiliency part at the application level and make sure that you're still returning something to your end users. And now, let's go back to the presentation, not the complicated thing. In other words, what I did earlier was to do the detection control, feedback control, and recovery control via the annotations. And here's the thing. Detection control is used by, it can be done via circuit breaker, timeout, and retry. Why? Because all these three are there to detect the faulty mode. They're there to help you with the faulty mode. Okay, retry is more like a believer that things can be better and it retries things. But it's there to help you in detection part as well. Feedback control. Now, this, the ones that give you feedback constantly, of course, first of all, is fallback. But you also get feedback when you're using the circuit breaker because it's looking at the part of your, it's looking at the percentage of your failure ratio, but it's also trying again. And you also get retry. And the retry is also giving you a feedback what this has tried and what has worked or not. And recovery control, of course, fallback. Fallback gives you a default until something is good is happening for your app. But circuit breaker as well, because that's one who's going to close the circuit so that your app is going to run in the normal mode, is not needing the fallback anymore. Now, this was the app level resiliency part. But what about connection issues? Because sometimes we're coding at our best the apps, but the fault is in the infrastructure or can be in the infrastructure. And you rely a lot on the network part. Now, for the connection issues, my own recipe, a big fan of Kubernetes or OpenShift, in my case for today. And what I'm going to need for this one to demo to you, I'm going to use a deployment activity. I'm going to deploy an activity. And that one is labeled with V1. That's why you see here deployment activity V1. I'm going to use also another deployment called V2, same, but labeled with the 2. Both of them are accessed via a service called activity. So both of them are reachable via activity. That's it for the Kubernetes part. But to add some resilience, I added Istio, because Istio is also coming with its own circuit breaker. And we're going to use that. So circuit breaker with Istio, what it means is that somebody requests something from your app, and that is being done in browser or in mobile or wherever. But that is done typically via a host name or via something more nicer than an IP, right? What happens is that thanks to a gateway config done in Istio, that request is being translated for the ingress controller. And thanks to the virtual service, that can be routed better to a service or to a deployment application deploy that can give you the best or the shortest answer, of course, if you know how to tweak things. And I'm going to show you how. And last but not least, you can choose the destination rule. And at the destination rule part, we're going to apply the circuit breaker, because at the app level and interacting with the deployment, we should add our destination rule. And those being said, let's go back to coding and hoping the internet will work. Okay, let me see if this one replies. Otherwise, if you give me a second. OK, this one is fine. So at least I can talk to my Kubernetes/OpenShift instance. OK, let me just place myself in the namespace activity. OC project activity is just the same thing as setting the current context to the namespace activity. And let's look at what we have to do. So first of all, we need to deploy the apps, right? And first of all, we're going to see the app without the circuit breaker pattern. What's happening? And I have my deployments. Let's add them here. First of all, I'm going to deploy the backend V2. And this one is deploying a deployment and a service account. Now let's add V1. And V1, it has also the service part. So I was a little bit lazy, and I didn't want to do it separately. By the way, if you're worried about the route, don't worry. Besides the route, you found in the GitHub an ingress specification so that you can use it in Minikube as well. And next, I need to create the gateway, right? Let me clear this. and make this bigger. So the gateway, it's going to interact, and it's going to interact with the internet, right? And it's going to do the awesome stuff. And next, what I need the place to enter the gateway. And let me show you why I'm coding the gateway, because it looks this big, and I cannot remember this kind of stuff. Next thing, let's deploy the destination rule. And the first destination rule without circuit breaker pattern applied at Istio level is available here in Kates. And it's very simple. So what this says is like, OK, if you're coming on the host activity for this service, so what you have to know is that for the host activity, there are two subsets that you can select as destinations for your request. The version 1, the one that has label version v1, which our first deployment, the deployment v1 of the activity. And there's version 2 of it. But in Istio, we're proxying it with different names. And you can give whatever name you like it here, as long as you remember how to use them in the rest of the configuration. So this one was the first one that we're going to deploy, and nothing fancy for the moment. And there's also a default virtual service, not the timeout, this one. And this one is just saying on anything, use the gateway, activity gateway that you deployed earlier. But if you find the /activity prefix, go to this port number, search for the destination activity, and so on. Simple as that. Let's go with it. Clear this. And now let's simulate how 4 concurrent users would send their 10 requests to an endpoint that is throwing timeout. So now the concurrent users are happening. I'm using a tool called Siege that's preparing the users for me. And this will take a while to be done. But I want to show you the entire process and how things are failing. So first of all, this endpoint timeout is throwing a 504. I coded specifically like that in here to throw a 504, yeah, on gateway timeout, although it returns some information. And we need to let it do the magic. Hopefully, it's not going to take longer. And while we wait, OK, so it's done. What we need to know is like elapsed time. So the time for my requests was very big. It was like 53.65 seconds. OK, everything failed. Bad. And the longest transaction was at 7.49 seconds. So it took kind of time to do that. Now let's fix this by adding the circuit breaker destination rule that has a way to handle the max pending requests when things are failing. It allows max for concurrent connections. And if there's a max request per connection to a container to ready to 1, it will throw a 503. So let's do this one, and I'm using this part here with simulating. I'm just copying from this one so you know how to replace it and for your own examples. Let me clear. And do again the same siege. But you can see that in the last time, the requests were, this one fails too. It was a 503 because it's timeout. But last time, the requests were like 5 seconds, 7 seconds. We're taking a lot of time. And the idea is at least to fail fast when you are failing, not to wait a long time and things not to go great. OK, the longest transaction took 12 seconds. That's not good. But the total time for the entire transactions were failed, true, was 21 seconds. So this means that when you're applying the circuit breaker, it can help you in failing faster, and you can detect things and when they're not working as expected way faster than without it. That's the story behind it. Now, going back to the slides, I showed you how these things are working. But What I invoked in my siege was something, a special case. Another special case that I want to talk to you now is about load shedding. And according to Site Reliability Engineering book, load shedding is that practice that is dropping some proportion of the load, meaning it's helping your load by dropping traffic as your server is cannot handle anymore the situation that's going over there. There are too many requests. And right now when you see drop, you're kind of thinking, so what we're doing to our users? We're dropping their requests? Well, not necessarily. And I want to talk to you about a technique that you can apply at application level, so Java application level, by the way, with a nice library called Bucket4J that is using token bucket algorithm. And this is what's depicted here in the picture. So what this says is that you have a bucket that allows requests, that has a size B, its capacity is B. When an incoming request is coming, that incoming request gets into the bucket and is compared to the bucket size compared to the number of requests that came. If that incoming request is not bigger than the bucket, then the request of the user is being served. If not, if the bucket is full, then you should drop, prioritize, or send with low priority. The idea of dropping is like a last case scenario. Dropping probably is the easiest thing, but I would advise on prioritizing or sending with a lower priority, and there are techniques on how to do that. We'll show it to you in a second. And there's another thing that you should know, that there's a refill rate. So once your bucket is full, you can refill your bucket. And when you should the duration to refill your bucket is given by the size of your bucket over the refill rate. So added some math to this so that you would know where things are coming, or when you're wondering how to do this on your own, this is the math behind it. And now that we are done with the rate limiting part in the slides, let me show you how that works at Java level. So let me go to the random hobby resource, make it bigger, and I first initialize my bucket. So I had the bucket for the dependency added to my app, and I initialized my bucket. Now, before giving, I put my bucket as a field, sorry. I didn't initialize it yet. But I also need to give a limit for my bucket, and I can do that with bandwidth. Now, the bandwidth, what it does, it adds some limits to your buckets. It's the one that's looking over the capacity and the refill. And what I said here is like, hey, the limit for my bucket is as follows. It has capacity to 20. And refill it with the greedy algorithm for it. There are more algorithms, by the way, to refill the bucket. And refill it with 20 tokens when the duration of 1 minute expires. So what this means, if 20 requests are sent in a minute, they will be in your bucket. But when 21 is coming, it will say bucket full. So now let's uncomment this part and add our limit. When you're nervous, add limit. And let's add a limit. A nice feature of Bucket4J is that you can add multiple limits for your bucket to evolve. So you can have multiple of these and just continuously add them and to refine your bucket. But for today, I just wanted to use this one as example. Now let's code the bucket at the limited response. Now this one returns 200 OK, but I wanted to use the token bucket algorithm. So what I do, I'm instantiating a consumption probe that is actually checking. Is returned by the checking on the bucket. So if I'm trying to serve this request, I'm trying to consume it, and then I'm trying to also return the remaining size of my bucket. Now, if my bucket is not full, this means probe dot is consumed, then return the remaining tokens. And the way to do that elegantly, because you're not putting that on your answer to the people, but you need to signal that to other apps, is by adding a header. You can add the header x-rate limit remaining, and you get on this one probe.get remaining tokens. Now that's the part for the good good moment. But what if the bucket is full? Well, if the bucket is full, you need to wait some time to refill the bucket. But also it would be good to return something to your users and also say to those that consume you in another status that you should return and that they should retry later. So you warn them like, hey, retry later, because this is the amount of time you should wait for the bucket to be refilled. By the way, this library works very well with Spring Boot. There's already something done there to work seamlessly as well. So this is the part for the bucket. Now, how do you test this? Well, that's easy. I made a test. So I have the test limited cached endpoint that is running 20 requests. And on those 20 requests, my expectation is that, okay, everything will be fine. So the header that I receive is to X-rate limit remaining. But when my 21 gets done, 429 is being thrown, and it says retry after several seconds. Now, I need to know if this one is not run. Maybe it will do this. MVN test. It doesn't work anymore. What's wrong with you? Anyway, we'll check about it. But please do check out the repo. I'll share it at the end. It works, trust me. It's just a simple unit test. So this is about rate limiting at the application level. But how about concurrency control? So there's another way to apply load shedding. You can do it at the infrastructure level most of the time with a proxy. And there are several proxies that you can use for concurrency control. That's HA proxy that OpenShift has as well in order to have this better concurrency control. There's also nginx, if you're using it as a proxy. Or you can have Envoy, for example. That one has very nice adaptive concurrency control in it, which is very nice. But in our case, I'm just going to use a very simple situation with concurrency control via Istio. So what I did, I'm going to use a destination rule and a virtual service. But in the virtual service, I will assign a priority for the requests that are coming from Safari, for example. That's something that can be done. So it's a nice way to prioritize your requests. The simplest way to prioritize requests is via the browser that those are being sent. There's one way of doing this for the limits. And now, and thanks to that, the priority, if I'm not mistaken, it will share that always will go to the version 2 of it. So let's apply that. By the way, you find the priority example in here. And first of all, I'm getting back with my destination rule to a simple destination rule, no circuit breaker. OK, clear. And let's apply also the virtual service for Safari. This one is very, very easy. It has the filtering based on baggage user agent. If it contains Safari, then do this. And of course, it will say if any request is coming on V1, just route it to V2. So let me here, clear. And now instead of siege, I'm going to use curl because I want to show you something visually. OK. Let me get this one. OK. And opening this in Kiali, traffic animation should be working soon. It will show you how things are routed. Hope the internet is going to help me. Better. So you can see here that when requests are coming, they're all the time routed to the version 2. Because they're coming, by the way, the requests are coming from Safari. If I was too fast with my curl, it has a -a Safari in it. So that's how I say the agent is Safari. So that's how it knows how to route it and how to put it. And Kiali is very nice for visualizing how your network is behaving at some point in time. I really like this part of the animation. And especially when learning different patterns, how they work, it's good to visualize it with this. Depending on time, I think I can show you also how you can see it in Grafana, how you can see the workload in Grafana, and yeah, I also have configured that. So this is pretty much the part of routing when you are trying to assign request priority, and you're using the browser that you're using, that the person that's invoking to access the endpoints. Now let me end the joy here, because it was enough, and go back to the presentation. So how about autoscaling? Because some of you probably thought like, hey, but if it's a lot of workload, why can't I apply autoscaling? It just scales things for me. If it's a lot of workload, it's all good. Well, autoscaling on itself is good, but doesn't solve all your problem. What you can do is to interplay autoscaling and load shedding. And how we can do that? So assuming that you have an autoscaling condition, so this is the sign for autoscaling in my picture, you're having requests coming. It's fine. Now the workload is increasing, and you can see it gets closer to the line of autoscaling. But thanks to load shedding, the stress over the system is reduced. This is good. Now load shedding stops at some point when things are going normal, right? Because it seems that the stress is reduced, so the system doesn't need to apply load shedding all the time. What you need to do is like check if the increased traffic is continuing. So that's the moment, so when the load shedding stops, you need to try to see, hey, is this traffic load still going on? Because if it does, that's when you should trigger the autoscaling part. And that's when you should do it, because if something is going on continuously, like putting a lot of effort on your system, it's not enough just dropping some things and making an economy on the short term. You would be needing to think on the long term if your workload is applied continuously. If not, then you're happy, you're in a good place, you don't need to worry about your system got back to normal, you just solved your problems with load shedding. That was enough. Now, last thing that I want to show to you is how to fall back with Scooper. What's Scooper? So, it's my new best friend and the thing that I'm having fun with. Now, Scooper is there to help you with multi-cloud communication for Kubernetes. But it can also work in your same cluster. It works across namespaces as well. And that's how I used it in my example, so that everybody can reproduce this at home. And it's very easy to install, and they're easy to manipulate. Unlike Istio, that requires a little bit more things to do in order to install their stuff, this one is much more easier to work with. The reason being is because, well, it's a little bit lighter, but Istio has its advantages in terms of control. And with Scooper, I have some examples. Let me see. I think I can do it myself. So this is the Scooper setup that I gave you. I have 3 namespaces. The first one is Benelux, the second one is CE, the third one is UKI. Now, what I did in my Benelux, I have deployed the backend Benelux, the one that I used earlier as well. I annotated my service with activity and the activity service with Scooper.io proxy HTTP. And what I did further is like to put my front end and, well, init the console of Scooper. I did similar things and also generated the token in this one, like saying, hey, this will be my primary place where I want to interact with this application. It has a front end and a back end, and I want to interact when I'm in Benelux. But maybe my back end is not all the time reliable. And it's good to have a fallback at another level. So this is why I moved myself also to another namespace called CE, installed backend there too, annotated it, and simply with Scooper I did Scooper init, and I've used the token earlier to tell that, hey, this namespace should be bounded to the other one from network point of view for load balancing purposes and also for fallback. And last but not least, I have done the same thing for namespace UKI. You can do this for as many as you want, as long as you use these simple commands. So it's way easier to deploy it and to interact with it. So let's see its magic. I need to find where my app is. So my front end is, of course, in Benelux. And I need to get this route. First of all, let me show you how Scooper console is looking like. So this is my Scooper console, and it has a nice view to see the graphic. And you can see that my deployment. So I have my hobby front end that gets information from my activity backend from Benelux. It also gets information from CE if this one replies faster, and also from UKI if this one replies faster, or this one is at fault. And we're going to try 2 different scenarios. Which one you want to see first? Like kill things, or so who's for killing things? I like that. OK, so let's kill things. But first, let me open the route for hobby. Oh, come on. Oh, yeah, hobby. I scaled it to 0, sorry, before the talk. No. Sorry, before the talk, I scaled to 0 my front end. And I'm scaling it to 1 now. I killed everything. So, OK, let's destroy and scale to 0 the pod that's for the backend from Benelux. And OK, let's try the route here for front end. And let's send some requests, depending on how internet is working. So you see that I'm getting responses from CE and UKI. These are the workers from CE and UKI for the backend, all the time. OK. Good. Let me see. I know how they stop. I don't know how many times I clicked this. But we want to like put things to die to a little bit more, right? I think I clicked 8 times. So now it's to 8. OK. Now let me go to the one in CEE. I'm going alphabetically, and put this to 0 as well. So I'm now relying only on the backend that's on UKI, if I'm not mistaken. If I'm looking to Scooper, the console gives me information as well. This one didn't change, 13 requests, it was before. This one changed, this one changed. And yeah, it can tell you where the load was. Let me go now here, and CE is at 8, right? So now when I'm sending requests, it should only go to UKI. And you see, the only UKI is becoming and growing bigger, because it's the only one that is giving you answers. Now, this is for the fallback part, and that's on the slides. Now, let's scale things to 1. Because Scooper can be also used for load balancing. And I want to show that to you as well. Come on, internet. Do not fail me. OK. Not activity. OK, good. Scale me to 1. OK. Now things should be back to normal. And let's balance things. So now when I'm sending the requests, Scooper is going to choose where it's sending it. And you can now see that it's serving from the closest, from Benelux, for example, or when it's feeling like it's serving from the rest. So it's balancing the request across these namespaces. And imagine that done at cluster level and across multiple cloud providers. Really reliable, right? And just with some simple configurations. And it's very secure, by the way. It works with certificates. I mean, in my example, I keep it at minimum, but it works with certificates as well, and it can even go a little bit more secure than just this simple example. So this is for load balancing with Scooper. Also, the example is provided in its repo. And let's make this bigger and to explain what happened earlier when we were like lowering down the pods and there was just one backend responding at some point. And I kept this only for 2 namespaces because, I mean, adding the third one, it would have made it even more complex. So what it did is that when I sent a request, my frontend received it and said, hey, get me an activity. But Scooper was the one that's like talking and proxying the backend and says, hey, I'm trying to get this from Benelux because it's the closest one. The backend from Benelux is the closest one. But there's a connection issue. Our pod was like scaled to 0. There was nothing there. Scooper sees this and speaks to the initialized Scooper from the CE namespace and says, hey, do you have something for me? Maybe your backend works. And this backend, in this case, it works. In our case, it didn't. I scaled it to 0. And it went even farther to UKI namespace. A response was sent, and the response was sent, and the response sent, and the frontend got a response. So this is how Scooper is proxying things for you, so you can get something regardless if something has failed and is not working anymore. And as I said, I kept this simple for the level of the 2 namespaces, so it doesn't become or grow a little bit more complex than that. Before saying thank you and everything, in my setup that's done on OpenShift, but I've depicted a similar setup for Minikube as well. I tried it myself. What I want to show to you for the part with Istio is that in my setup that I have for Kiali and so on, let me go to Istio system. Okay, and go to routes. I have also Grafana. So when installing the service mesh here, I have Grafana and Istio, and I am able to get some defaults about my workload and how my workload behaved, regardless if I know how to do Grafana charts or not. Before experiencing with this one, I was doing my own charts, and I'm still doing my own charts sometimes. But the thing is that you can see here different workloads, how they behaved. And I think it's easier to see how they behave in the last 30 minutes and what was the success rate on each workload. So the part with the infrastructure and Istio and so on, it plays and interplays really nice with all these tools, and it gives you a good control over what's going on with your app. And you can see also the traffic, how the requests generated, and so on. So it was not just me doing requests from my local, but they are also monitored in Grafana and seen there and observed there. Now, first of all, thank you. The code is available on GitHub in the resilience repository. It's all documented there, all the steps and everything. It's a little bit more on the Istio side, but I hope you would like to play with that one as well. And of course, if you scan this, you get the slides that also get you something like this. So you get 2 more free books that you can download. One about Istio and one is Quarkus for Spring developers. If you like a Spring developer and you'd like to get to know how Quarkus can help you, please read that one. By the way, both of the books are really short and concise.